Hello everybody, good evening and welcome to another edition of Serverless Days Belgium, the virtual meetup edition. We are live, I think you can see me and I think you can also hear me. I look at my assistant, yes, she's telling me that I am very well understandable. All right, the third virtual meetup, and as you see, I am already fully in the Christmas spirit. But I'm also wearing something else next to my Christmas hat. I'm wearing this very nice Azure bear on my chest. And that is because today we are exploring new horizons with Serverless Days Belgium. We have our first sessions here tonight about Azure and about GCP. Well, the first session is the one about Azure, session given by Mark Daker. He's talking to us about dealing with persistence in serverless applications on Azure. And it's actually a very interesting talk. I have already seen him, but I will gladly watch him another time now. And then next up at 8:15, we have Renaud. Renaud, who is talking about Firebase, the serverless platform from Google. Renaud is a real Firebase wizard. I have seen him at work firsthand myself already. He's going to do a live demo for us tonight, so I'm already praying to the demo gods that everything will be good from my side and that I can bring that content to you as you should get it. All right, with that, yeah, maybe I should thank you also. Thank you for being here and sharing the serverless spirit and the serverless mindset with everybody. Let's keep doing that also in 2021. I hope that we will then finally be able to organize the real conference in Antwerp that we had to postpone this year because of the COVID crisis. All right, with that, it is time to start the session by Mark, dealing with serverless applications, dealing with persistence in serverless applications on Azure. Enjoy.
Hey, Serverless Days Belgium. Today I would like to talk about how to deal with persistence in serverless applications. Before we get started, a little bit about myself. I'm Mark Duiker. I'm from the Netherlands. I'm an Azure MVP. I work for Xperit in the Netherlands. And by the way, Xperit also has an office in Belgium now. And I like to do a lot with serverless and event-driven architectures. You might also know that I have a YouTube channel, and once every week or so I try to record a Azure Functions related session together with Gwyneth Peña, and that series is called Azure Functions University. So if you're new to serverless and on serverless on Azure, then I'd highly recommend you to go watch that. I also really like to draw pixel art. So I also made this GIF. So yeah, it's really something I really like doing, and I'm doing it more and more lately. So if you want your own pixel avatar, drop me a note and I can make you one. But let's get back to the session. So what's the problem here, right, when we talk about persistence and serverless? Well, if you go back before serverless was there, so if we look at traditional persistence options when we're dealing with a server, that could be a web server, how would you store your data then? Well, if it's small bits and pieces of data, you could choose to store the data on the hard drive that is on the server itself. So you could maybe use that for caching or for data, or just simply storing some small business objects there and retrieve that later in your application. That would have been fine in the, let's say, pre-cloud and pre-serverless days. If it was more like a structured data, then you would push that to a database like SQL, for instance. But when we're talking about serverless, then we're not just talking about one server or one virtual machine, but then we have a whole range of servers or virtual machines. So it doesn't make sense anymore to just simply store a piece of data which lives in the same process as your serverless application lives, because there are many instances of those virtual machines. So if you store a piece of data on one instance, that piece of data will not be available in one of the other instances. And since it's serverless, when nothing is used, that means also all these servers or virtual machines are decommissioned and not in use anymore. So all the data is then also gone. So you're not persisting anything then. So that's not a good thing. The other issue when it comes to, let's say, using and connecting with regular databases is that when you are scaling out very quickly, and when the workload is very high, and many servers are then turned on and will do work for you. But it also means that if you want to save some data or want to retrieve some data, that makes a lot of connections to your database. And if you're not aware of that, or and maybe you don't think that might be an issue, then you can run into real problems. You can actually overload your backend or your database with all these connections and requests. So the persistent challenges in serverless all have to do with scale, and there are really scaling issues because your VM scale out and the number of connections scale out to your database. So that's quite tricky. So the scaling issue was already there before. So if you're dealing with high load, you already had to think about these things. But with serverless, it's immediately a problem because serverless is ideal for workloads which vary quickly. So it's definitely something to think about from the start. So what's the solution? Well, the solution is definitely looking for scalable storage, and definitely storage that's out of process. So it doesn't live in the same process as the compute part of functions. So in this session, I'm going to look into 4 different options, and that's different storage options that Azure provides. There are definitely more options, but otherwise the talk would be too long. And I specifically chose these 4 options, so blob storage, stable storage, Cosmos DB, and durable entities, because I think they're very serverless friendly and also developer friendly. Because as you'll see, I'll do some demos. You don't need an active connection to Azure to actually develop against blob storage or table storage or Cosmos DB or durable entities, because all of these storage types can be emulated on your local machine, which I think is very nice. Let's take a step back and look at Azure functions and how data can work with your Azure functions. Well, functions always have a trigger, so that can be an HTTP trigger, but it can also be that a blob trigger. So whenever a new file exists in a blob container, your function will be triggered. It could be a queue trigger. So that's pretty standard, and of course some data can come with that trigger. But the nice thing about Azure Functions is you have these different ways of configuring your inputs, but also your outputs. So, and these are independent of the trigger you use. So we can have an HTTP trigger, but we can have an input that is configured to a blob store, or we can have an output that's configured to table storage. So these things are called bindings, input and output bindings. And they're really the most powerful thing, I think, of Azure Functions, because just with a few lines of code, it's very easy to get more data into your function or move data out of your function. So let's start with the blob storage. So blob storage is part of a storage account in Azure, and it exists already for a very long time. And that's mostly used for unstructured data, so large amounts of unstructured data. So that basically means files, and those could be JSON files, or it could be zip files, or complete virtual machine images. That all counts to files. So the structure of blobs is as follows. You have a Azure storage account, but in that account you have different types of storage. But one of the types of storage is then blob storage. But blobs always live in a container. They live in a blob container, and you can see that as a kind of a folder. And a blob itself, you can see that as a file. And then there are different versions of blobs, or different types of blobs. So these are page blobs, which are then used for virtual machine images. You have append blobs, and those are very useful for logging. So they always append to a log. And you have block blobs, and blocks are the most commonly used for other types of files if you just store JSON files or zip files. Okay, let's go to see some demo code. But actually, before I do that, we should actually switch to the browser, because as I mentioned, I'm running this completely locally. So I've got VS Code, which I'll show you in a second, but I'm not connecting to Azure at all. So instead, I've downloaded several tools. First, I have the Azure Storage Explorer. And the Explorer is just more like a tool for visualizing and managing your storage accounts. And it can do that for emulated storage, but also it connects to Azure itself. And it runs on Windows, Mac OS, or Linux. It's a free tool. It's very useful. Nothing to do with emulation just yet, but just a very useful tool to have in your local development machine. The other tool I use is the Azure Storage Emulator. And like the name implies, it actually emulates your storage account, and you can use it for emulation of blob storage, of table storage, and of queue storage. So it's a very nice tool. As you can see here in this important highlighted box, it's no longer being actively developed. So they're actually moving away from this tool, and they're preferring another emulator called Azurite. So if you're still using the Azure Storage Emulator, it's fine. But at a certain moment, you're probably better to switch to the different tool called Azurite. Azurite is a cross-platform tool, and Windows Storage Emulator is only for Windows. So that's important to be aware of. But at the moment, the Azure Storage Emulator has a bit more options. Specifically, it has emulation for table storage. And the table storage emulation is still not finished yet in Azurite. So Azurite is fine for queues and blobs, but not yet for tables. So that's good to be aware of. So this is the page about Azurite. I have both installed actually. I have Azurite as a VS Code extension, which works very nicely. But I'm still quite used to the storage emulator, so that's what I still use in my daily work. Then we have the Azure Cosmos DB emulator. So again, for Cosmos DB, global redundant NoSQL storage in Azure, and that also has its own emulator. And I've also downloaded that. It has quite a simple web interface where you can create new collections there and insert items there. You'll see it in a couple of minutes. So that's also what I have running, and that is both an emulator and a UI. Okay, so now we can go to VS Code and have a look at the demos. So here I have my serverless persistence Azure Functions project. It's in .NET Core 3.1. I have several subfolders, and I will start with the blob examples. I've got some examples for blob input and blob output. I'm going to start with the output. I've got too much demo code to show in this one session, so I'll just pick, I think, 2 for each input and output. And I'll provide a collection of links at the end of the session, so you can look up everything in your own time. So let's start with this function. So this function is an HTTP triggered function, and when we do a post and provide a player object as the body, so that's what this means. And if we look into player, so this is the definition of player. There's an ID, it has a nickname, it has an email, and it has a region. So that's the player part. So when we provide that in the body, this function is triggered. But what we also have configured here is a blob output binding. So by using this blob attribute, you see here, we only have to supply one parameter, and that is the full path of where the blob will be stored. So in this case, we are configuring that the blob, which will be the output of the function, will be stored in a player's container, and then in an out subfolder, and then with a name called string hyphen, and then this is something specific for Azure functions. These are called binding expressions. What this does, it will generate a random GUID at runtime, and that will be used as the partial file name of this blob file. And we also specify that we want to write to the blob. So there's two parameters, the blob path and the file access. So here we define the type. We define it's an output type, and we define it of type string, and we have the name. So what happens then in the function itself? Well, not too much. We just check if the input isn't null, and if it is null, we return a bad request. But if it is not null, we'll actually serialize our player element and do some formatting on it. And just by assigning it to this output parameter, we've set this, and then the blob binding will take it over and will actually store it in blob storage. And finally, we'll give back an accepted result just to notify the client that our action was successful. So let's run this. So now I'm starting this function app locally. It's starting up the Azure Functions local runtime. So that's what's happening here at the bottom. Yeah, so now the Azure Functions core tools is starting, and we see in yellow all of the names of the functions, and in green are then the local URLs. Okay, so in this Git repo next to the source, I also have a test folder, and in there I have a collection of .http files. And I'm not sure if you are aware of the REST client in Visual Studio Code, but that's a very nice extension. It's comparable to Postman, and if you have these .http files, or could also be .rest files, you can put your GET and your POST request in these files. You can execute them straight from VS Code. So what I've defined here, I've defined a base URL, which is the base URL of my local Azure function when I'm debugging. And then I've appended it with the specific function name that I've just shown you. So in this case, we're doing a post to this base URL to this function, and providing a JSON payload, which is which can be converted to a player type because it contains an ID, it contains a nickname, email, and region. So let's do this post, and then we'll see the response here. It's to accepted, so that means that it has succeeded. So now let's go to the Storage Explorer, which we haven't seen yet. So this is the Azure Storage Explorer. I'm already somewhere which I don't want to show just yet. So this is the Azure Storage Explorer. So it's connected to my emulator storage, which is this node emulator. And in my emulator storage, I have blobs, queues, and tables. But I also have my Azure accounts here. So this Storage Explorer can be used for both things in the cloud and things on your local device. So we're talking about blobs now. I have some different blob containers, but there should be something in this container. And the code mentioned we're using an out subfolder. So this was not there before, the out subfolder. So the Azure function, the binding created it for me. And if you look in this out folder, we see the blob with this generated name. So I can double click it. It will then download it for me from the storage emulator. So it now says transferring. Yeah, and if you switch back to VS Code, we'll see that it opened here. So this is the part that has been stored. So that worked. Perfect. So that's one example of a blob output binding. So let's do another one. We go back to blobs. Let's choose the container blob output. So again, what we see here is an HTTP trigger. Exactly the same signature is doing a post. We are again providing a player object. But what we now have is, alright, we have again a blob attribute as the output binding. But currently we only supply the name of the container. So we don't supply the full path of the blob, but just the container name. And I have that as a constant string in a config class. So I don't refer to the string immediately, but I have it in this constant. Again, we have the file access right, but now we are referring to a cloud blob container. So what this means that in our function, we can use this cloud blob container, which is a reference to the container in blob storage or your emulator storage. And we can then add blobs to this storage. So I do the same check here if the player is null, and if it's not null, then I'm using the cloud blob container to first get me a reference to a block blob. So you first need to create a reference. And by creating a reference, it basically means, okay, just give me a reference to the blob and make sure you've set the name. So in this case, I'm setting the path again as out/ and then cloud blob hyphen, and then we can actually use a property of the player as part of the file name. And so that's something we couldn't do in the previous example, because then we had the random GUID specified in the blob output binding here, but we couldn't use any properties there. But now we can actually say, okay, I want to use something identifiable of my player object. And also note that this out folder, and that's more like a virtual folder. So it belongs more to a file name than it belongs to a folder. It's definitely not a container. So the container is players, and in there you have a virtual folder called out, and then you have the file name is then this part. We serialize the player object again, and then we use the blob reference, and then use the upload text async methods to actually upload what we have serialized here to the blob. So let's also run this one. The application is still running, so I can get to my test file. So that's this one, store player with container blob output. So this is the player object we want to output to the blob. Gonna send a request. It has a to accept it. So let's switch back to storage. You don't see it yet, but if I refresh it, yeah, now we have it. Cloud blob blob Margaret. So that's good, that works. All right, so let's do the reverse thing now, because these were output bindings. So something gets in via HTTP in this case, and then we output to a blob. But now let's do the other way around. We want to do a blob input. So we want to read something from a blob and use that in our function. So again, we have several examples. Let's first do this stream blob input. So again, I'm using HTTP triggers because they're just very easy to work and demo with. Oh, wait a minute, I should switch back to my VS Code. So this is the first example of a blob input binding. Again, it's an HTTP trigger. This time it's doing a get method. And I specify the route here. So it's basically the route is the same name as the function, but then with a /id. So we can use route expression parameters. So when I provide the ID like this, and also mention the type of the ID, it's a type of string. Here I can use the ID in my function. So whenever I do a get player with stream blob input / and then I provide a GUID for the blob, I can actually read that into my function. Again, I'm first doing some checks if the ID is actually filled. So if not, I will give a bad request. But if I do have the ID, I create a new stream reader, and I'm reading from my player stream, and my player stream is what I've configured here in my blob input binding. So this is important to note now. So I'm actually using this route, the ID in the route, and I can reuse that ID now in my blob input binding configuration. So I'm referring to the players container, and then the in virtual folder, and then to a file called player, and then hyphen, and then an ID. So that's a stream. And what I'm doing here in code is that I'm reading the stream to the end, and then I'm providing a content result back, setting the content, which I've just read, and I give back a status code 200 with that content. So now let's do that. So let's go to our, not our blob output, but our blob input. So let me first switch to the Storage Explorer again. Here we go, because if we move up, we already saw this out folder, but now we're actually going to look into this in folder. And this is something I have prepared up front. So there are two files in there, player hyphen, and then a GUID with 470, and then a player with hyphen 4CE. So now let me go back to the code again. So I'm going to execute this function we have with stream blob input, and then I'm going to use this ID. So this matches with the ID you saw just before in the Storage Explorer. And let's do that. And we get back a 200 OK. And this is the content of the blob that's in blob storage. So that definitely works. All right. So let's do another example of blob input. So, well, let me actually check if I have this as an example. Oh yeah, maybe it's nicer actually to do this one with the container. All right. So this demonstrates that you can, instead of reading just one object, you can also retrieve a list of objects that's in your container. So again, we have an HTTP trigger. We have do a get method. We don't specify a route this time. But what we do here is we have a blob input binding, which just points to the player's container. And we'll just do read there. And then we have access to our cloud blob container object again. And we will use this cloud blob container in our function. And what we do, we can use this list blobs method on that cloud blob container, and we can actually specify what we're looking for. So in this case, I want to say, okay, give me the blobs in this cloud blob container, but I'm only interested in the blobs that are in this in virtual folder. So that's why I'm saying prefix in. Then I'm going to cast it to the type cloud blob blob. And so that will have me my blob list. And then I actually have because I have the cloud blob blob, I have some properties on that. And one of the properties is the name of the blob. So what I'm actually outputting is simply names of the blobs that are in there. So it returns a 200 OK with then the names of the blobs. Okay, so let's run this. Blob out inputs this one. So that's its final one, get blob names with container blob input. And there you go. We have a list of two blobs, one with the ID 470 and one with the ID 4CE, which was also what we saw in our Storage Explorer. So just two different ways to use the blob input binding. All right. So those were the blob samples. So storage accounts, they scale really well. They can contain really gigabytes of data. So it's very easy to integrate them with Azure Functions. So I think this is a really good match if you want to simply store small pieces of data in storage. The next example is table storage, and table storage is also part of the Azure Storage account, but it's also available as Cosmos DB. The one I'm going to demo though is part of the storage accounts. So yeah, how can you use this table storage? It's mostly used for storing a large amount of structured data. So you have some sort of schema that you want to have persist. So if you look into storage accounts, so next to blobs, there's also tables. And if you want to interact with them, you first have to create a table itself. And that's kind of similar to, let's say, a table you have in SQL. And in that table, so the table itself, what's interesting about table storage is the table itself doesn't have a definition by its own. But as long as you put an entity in there, then it becomes defined what's actually in the table. Although you can put different types of entities in the same table, so that is possible. So an entity, it has several properties which are there by default, and that's the partition key, the row key, and the timestamp. And then it allows up to 252 custom properties. Yeah, so you can store relatively big objects in there. What is important to realize is that the objects should be, let's say, flat objects, because the objects are then serialized. And it doesn't really go well if you have, let's say, nested JSON objects in there. So if you have just let's say, a object which has many properties, but none of the properties are really deep nested properties, then you'll be fine. There are also some limitations on the type of properties that an entity can have. So I've put several links throughout this documentation, so I definitely recommend you to look into these links to know what the limitations are. So the most important part is the partition key and row key, because the partition key will be used how the data is actually stored and how the underlying infrastructure is actually scaling your data, so how the data is partitioned across the different machines. And it's really important that you select a good partition key, because you have to provide it when you query data. So you will have the most efficient queries if you specify both the partition key and the row key, but you at least need a partition key. So a row key, that has to be a unique value within a partition. So if you specify both, then you have, let's say, the primary key. So the combination of partition key and row key should really be unique. But a row key should only be unique within a partition. The timestamp will be automatically generated. You don't have to worry about that. Okay, let's go to some demos first. So let's go to table. Let's first do the output again. Yeah, so this is a very brief one. I always like these examples because some of these functions can be so incredibly short. So in this case, we have an HTTP triggered function again. And in this case, we get a player entity. And it's good to actually show this entity. I derive this player entity from a table entity, and that comes from the table storage. So as you can see, I have a reference to microsoft.azure.cosmos.table. So that might sound a bit strange, but like I said, you have table storage both within Azure Storage Account and also in Cosmos DB. But they have one API, and that's the Cosmos Table API, but that works for both types of accounts. So when you inherit your own entity from table entity, then you are sure that you have the partition key and row key, so you always have access to these built-in properties. So that's why I do it. The rest of the properties are quite the same, so we still have an ID, nickname, email, and region. But because this is a entity type now, we have to set the partition key and row key. So in this case, I have a method that if I get a player object without the partition key and row key, I can call this setKeys method, and then it will take the region as the partition key, and it will take the ID of the player as the row key. So we expect a player entity to come in, but that player entity won't have a partition key and row key set just yet, because we assume that the clients don't have any knowledge about table storage. So that's the responsibility of this function. But as you can see, within this run method, we don't have the table configured, but the table is configured up here, so at the top of the function. So this is quite of a weird syntax. We use the return attribute and then the table attribute, and by using this, we instruct the function that whatever we return inside the function, it should return to the binding we specified here. So in this case, we return it to a table, and I've captured the name of the table in a constant in this table config file. So the table is named players. And what happened inside the function is we take the player entity, we apply we run the setKeys method. So we have set the partition key and row key at this point, and then we simply return it. And that means we hand it over to the table binding to output it to the table. So let's run this. And again, let's open up one of the HTTP files. So we're going to do a post to this endpoint, and we're going to provide this payload again of yet another player. So let's do this. So we get back a 200 OK. So now we should go to the storage emulator and go to tables now. Then to players. We have several players, but I think it still contains some data of some earlier tests. Let me actually clean this up. Okay, so now everything is gone, and run the test again. So it's this first one. Let's execute it. We get back at 200 OK. Didn't see it, but I quickly switched back to VS Code and executed the function again. So now I'm here again, so let's do a refresh, and now we have our record. So let's actually double click it, because you can now already see the properties, but let's actually open this so you can see how it looks like. So you can see the first three are the predefined properties. So you have the partition key, the row key, and a timestamp. And the timestamp is generated, and the partition key or row key are selected by me. So in addition, I am still I'm still outputting all of the properties. So I'm still having a region property of United Kingdom, which is the same as the partition key, and I still have the ID as it came in, which is the same as the row key. So yeah, what I usually do is I don't hide certain properties which I use as a partition key or row key, but I simply duplicate them. And so in this case, my region is my partition key, but I still keep my region as a separate field here. Because maybe in time people forget what the original partition key was. Of course, there's a country in there, but who knows what the meaning is of this value. So I like to keep all my original domain properties in here, and I simply duplicate them if I can use them as a partition key or row key. So also note that we are dealing with structured data, because we can now add more entities here of type player, but they don't necessarily have to be of type player. As long as they have a row key and a partition key, then it's fine. So they can have different properties. So this is it's definitely not as flexible as blob storage, but again, you can actually query these tables very nicely. So it's definitely more flexible still than a SQL table where the schema is fixed. So you have a sort of schemas, but you can still deviate from them and add extra properties if you want. Let's switch back to code. So that was one example of table output. So let's do another one. This one. So this is more traditional way of applying the table output binding. So we have an HTTP trigger again, but it's important to realize that we are now accepting an array of player entities. So we're not just receiving one entity, but an array of player entities. And we've specified a table output binding here by using this table attribute and by only configuring the table name. And what we then have is an async collector, and then of the type we want to store. So this is quite different than what we've seen before. So before we were mostly dealing with a single blob or a single table entry, but now we're dealing with an array of entities, and you want to store the array of entities into the table. And Azure Functions has a very nice concept for that. So it doesn't only work for tables, it also works for other types of bindings. And that's the async collector. And what this collector is, it's more like it's really kind of an in-memory collection where you can add individual items to. And once your function is done, or you manually call flush to the collector, it actually flushes or pushes the data to the storage that's behind it. So in this case, I'm iterating over all my player entities in my array. So for each of them, I'm setting my row key and partition key, and then I'm adding them to my collector. So at this moment, nothing is stored in table storage yet. So finally, I'm returning my accepted result, and once the function completes, then everything that's in the collector will be flushed to table storage. So let's run this table outputs. This one. So I have an array of 3 player entities here. So let's post this. So when we look back to our in Storage Explorer, we should see 3 new records. So we get a 202 accepted. So now I'll switch back to storage. So there was only 1, but now there should be 4. And exactly, we have 3 new ones. Perfect. Let's go now to the input bindings of table storage. This is the first one. So what we have here, we have an HTTP trigger again. We're going to a get to this route. So it's a function name, but then we do a slash and provide the region, and then a slash and provide the ID. And by using this like this as the route parameters, and also have them available here as separate input properties, we can now use this table input binding and refer to the same properties we had as the route parameters. So what I'm saying here is, okay, whenever I have this get request, use look up an entity in my players table that matches the region and ID that I provide. So this gives me a player entity, and what I'm simply doing in the function is I just return a new OK object with the player entity that is extracted from table storage. So let's run this. So let's do the table input now. So I've already defined here the region I want to query, but I haven't defined the ID yet, because we started out with an empty table. We just added some records to it. So let's actually switch back to storage and select one of the elements here, because I'm going to query one of these elements because I already provided the United States of America. So let's actually copy paste this row key. So this is the one I want to query when I execute the function. So it's Margaret. Let's get back to VS Code. Let's put in the ID here. Okay, so we're going to make this request and specify the region and the ID, and it should return indeed the record with Margaret. So that's working. Cool. The other thing we can do with table inputs, this one, is we can actually query the whole table and to return potentially multiple records. So that's what this function does. So here we have specified a table input parameter, but we've only specified the table itself. So we don't specify a partition key or row key here. So we only have identified the table, and now we are binding it to this type of type cloud table. What we'll do here is, in this case, we are extracting the region from the query string, and then we will create a table query. And so that's a type dedicated for table storage, and the table query will actually return player entities, and we can use a link query here to define what it should look for. So what our filter is. So we are creating a where clause, and we are generating a filter condition where we look for one of the properties of the element. In this case, I'm simply looking for the partition key, but it can be any property of your entity, where the partition key is equal to whatever I'm providing. In this case, I'm providing it with the region. And so this is still a very simple query, but you can actually combine and nest these queries so that they become more complicated. And finally, when we have this, I call it a region filter. When we finally have defined this filter, we will execute that filter against the cloud table. And that gives us back a collection of player entities. So let's run this one. So we've already defined the region here, so we can just simply reuse that. So this is the function we're going to call, and it has a region query string parameter, which we're going to provide. So let's do that. And this is the result. So it matches the two records, because there were only two records for United States of America. So the first name belonged to Margaret, and the second name belonged to Grace. So that's a very nice way to easily query your data with Azure Functions. All right, 2 down, 2 more to go. Let's now look into CosmosDB. So CosmosDB is really a very nice NoSQL solution in Azure. It's very easy to geo-replicate your data very quickly and to really get very low latency queries going. So the service is really very big. It handles big and large documents. The very nice thing is that it also offers different APIs. I've mostly used the SQL API just for simply storing and receiving JSON documents, but it has many different APIs. So Mongo API, Gremlin API. So there are very interesting ways to put your data in there and to make it queryable. Like I mentioned, it's very easy to globally distribute your data. One of the key features is that it has a configurable consistency levels, so you can really configure it to mention, okay, well, whoever writes also needs to read the data immediately, or reading is maybe not so much important as writing, or just the other way around. So it's very nice to be very specific on what the actual use is of your NoSQL database, and that also has implications on the performance. So that's also good to know. I already mentioned the various APIs it has, and it also offers auto-scaling, so that's also very nice. what is actually new is that it also offers a serverless offering at the moment. It used to be that you had to define a size of request units, and that's defined in how so whenever you do a query or do a post to store data or to get data, that has a certain cost in request units. And before the serverless offering was there, you had to there was a monthly fee related to a certain size of request units. But now it offers a true serverless option as well, so you only pay as you go. So you really only have to pay for the number of invocations you make to Cosmos DB, and of course a part of the storage you use. So that's a very nice offering if you're just starting out, just starting to play with it, or expect to have a really low load initially. So definitely check that out. So when you create a Cosmos DB account, because that's the resource you actually make, you create a Cosmos DB account in Azure. Then in that account, you can create a database. And then in that database, you need to create a collection. And the collection is the thing that holds the records, so that holds the items or the documents. So the exact nomenclature also depends which API you use to interact with it. But on a very high level, you have database, collection, and items. And the most important part for the items themselves are the ID. So every item needs to have a unique ID, and you need a partition key. And the partition key is similar to what we saw with table storage, because partition keys are very important when it comes to querying. And it also is very important to realize that the partition key is also used how Cosmos DB actually then uses and groups your data based on those partitions, and in order to scale out efficiently. So yeah, choosing the right partition key is really very important here. Yep. Let's switch back to VS Code. And let's have some Cosmos DB samples. Oh, let me actually switch back to the browser first, because I didn't show the Cosmos DB emulator yet. So I've got the Cosmos DB emulator running, and it comes with a web page where you can show, for instance, how you can connect to it, because you need a specific connection string, which you need to configure in your Azure functions, how you can connect to it, and then you can just browse through your data. So here you can see that I have created a GameDB database, and in the database there is a players collection, and in the players collection there are items, and currently there are no items in there. I can actually create a new item from scratch here, but I'm going to do that via Azure Functions, and then we can come back and look at them here. When you actually create your collection, you have to specify which property is used for your partition key. So as you can see here, the ID is the primary key, but I'm using region as the partition key. Let's switch back to code. Let's first do the output examples again. Let's not run it directly, but let's first show some code. All right, so this is one of the most basic examples because it uses the same return attribute as we saw before. But in this case, it's of type Cosmos DB, and when you use that, you have to specify which database you're binding to. In this case, it's the GameDB, then which collection, it's called players, and then which connection string you're using. And the connection string, that's very important to realize. The connection string is the connection string setting. So what's specified here, and I've captured it here in a constant, but this is the name of the connection string key that is available in your local settings JSON. If you're developing locally, if you're running in the cloud, then it refers to application setting of your function app. So I'm referring in code to this key alone. So the code itself doesn't refer straight to this actual storage connection string. We're only referring to this key. So that's important to realize. So because we've specified this as our return attribute, it's bound to CosmosDB. So whatever we get in through our HTTP trigger, in this case a player object, we simply return that player object. It will be stored in Cosmos. So let's test that. So it's Cosmos output. So this is the one. We're showing a post and we're just posting this player object to it. And we get a 200 OK back. So now we need to go back to Edge and see what's there. So I need to refresh this. Yeah, this one. And indeed, our data player is here. You can also see with it next to our properties that we provide, it also has some metadata. So there's a timestamp, there's some e tag which can be used in case of collisions and stuff like that. So there is a bit of metadata use here, so which you might not immediately recognize. But that's worked. That's cool. So let's get back to VS Code and let's do another sample. So the other sample is we can use the collector again. Yeah, so it's a bit long. Let me actually break this up so it's a bit more readable. Right. So what we have is an HTTP trigger again, and again, the same as for the table example I showed earlier. We have an array of players. We've configured the CosmosDB as an output binding like this by specifying again the database and the collection and the connection string. But again, we're using the IASync collector. So we can add player elements from this array. We can add it to this collector, and then it will be flushed to CosmosDB whenever this function executes. So let's do this as well. Cosmos output. So in this case, I'm having 3 objects in my array, so I expect 3 additional documents in my CosmosDB. To accept it. So let's switch to back to Edge, and when we refresh this, yeah, then we have 3 new records. So that worked. So let's do the other way around now. So let's have a look at the input. Yeah, let's do this one. So what we have here is we now have an HTTP GET, and we specify the route, and in the route we specify the region and ID as part of the route parameters. The same as we did before with one of the table storage. And because we specified here as arguments and also here as parameters, we can also use them now in our query. But we're actually querying it as part of the configuration of our CosmosDB input binding. So this is our input binding. We specify the database and connection string as for the output binding. But now we also specify the partition key, which is then the region we specify, and we specify the ID. So we provide everything. So we can do a point query to the exact document we want. And that's of type player. That is then returned with an OK object result. So yeah, it's interesting. We actually hardly have to write any code to do a point query from Azure Functions and retrieving a CosmosDB record. So let's go to this example. So that's Cosmos input. So I already specified I want to have my partition key, the region, United States of America, but let's actually copy an ID that's actually in there so we can do this point query. So let's switch back to Edge. So let's pick this one, which was already open. So we want to retrieve this document for Grace Hopper. So that's the ID. All right, so let's send it. And indeed, we have the record, the document from Gracehopper. Perfect. Let's close this one again. And the other input example, that's this one. So that's a bit more elaborate. Let's first close this one. So what we specify here is we don't specify the query as part of the binding, but we specify the query in code. So it's a bit more work, but you're definitely more flexible then. So we only specify the database collection and connection string, and we have access then because we bind to a document client, and we're going to use that document client to actually do the query. So we'll first read the region, so we'll use it as a partition key from the query string. We will then create a document collection URI based on some factory methods that ConstantDB provides. So we have that collection URI, and then we use the document client and we create a document query. And what we expect back is the type player. We provide the URI and we give back, we also provide some feed options. So here we provide the partition key. So that's always important if you want to do efficient queries. You always need to specify the partition key. And then we do the query. So then we say, okay, I want only records where the player email is not empty. And I only want to get back the nicknames of the players. And then I'm returning that as a document query. So I have a query object there. Then I create a new structure which can hold the nicknames of the players. And then I'm iterating over the results of my query. And I'm going to do, for each nickname I find in my query, I'm adding it to my nickname collection. And what I finally return from the function is that nickname collection. So as you can see, quite a bit of more code, but yeah, you can be very specific here on how you actually want to filter your data and also how you want to massage your data, because I'm doing a very specific select here. I'm not returning the entire document. I only want to retrieve part of the document. So that's also very efficient then, because I'm not returning very big documents. In this case, the document is very small, but if you have big documents, it's always more efficient to only retrieve the parts you really need. So let's do this input then. So that's this one. I'm only specifying the United States of America as a region. And what we get back are the nicknames of the players who live in the United States of America. So that's Gracehopper and Margaret Hamilton. Perfect. So that's the Cosmos DB part. So the final part is maybe an unknown one to most of you. It's called durable entities, and durable entities is part of durable functions. So if you've heard of durable functions, that's a very nice extension on top of Azure Functions, and it allows you to do long-running workflows, which can last days, months, hours. So it's really flexible, and it works like that. It can work like that, and the long-running workflows, because it's actually using a storage account underneath. But the usage of that storage account is completely abstracted away from you. So you have the durable functions API, where you can schedule all kinds of tasks and activities. But underneath there, table storage and queue storage is used to actually manage that workflow and to persist that the state of that workflow. So yeah, using durable functions is a really efficient way to actually get stateful Azure functions. So durable entities is part of the durable functions, and some compare it to the actor model. Some find it a bit too much, but what is important to realize that you define an entity by name, and so that's a certain class or group of entities, and an entity always have a unique ID, and to pinpoint to one specific entity. So an entity is actually a class. We also see in code that it is really a class definition, and that class can have different properties. So one of them is indeed an ID, but it can have multiple properties that you can define yourself, and it also has operations. And so here you can probably see from that the actor model is also closely related to this, because actors are also classes, and actors can also have properties and operations. Yeah, so let's go to some demos again. So, durable entities. I have no input and output separation this time, but I need to show you how it works. So it first starts with a client, because durable functions, and then therefore also durable entities, need to start with a client function, which is a regular Azure function, and it's triggered by something. And in this case, I'm using my old and trustworthy HTTP trigger again. And this HTTP trigger works with both a post and a get, and it also has a route specified. So it's called a high score client, and the route contains a player name and optional a points indication. So what we actually can do with this is we can assign points to a player. So that's if we supply both the player name and the points, we can assign points to a certain player. If we omit the points and do a get, then we want to just retrieve the number of points a player has. So that's what we want to achieve here. And the thing which is new here is this durable client attribute and the iDurable client interface. And by using this binding and this interface, that actually allows us to interact with the entity itself. Well, in this case, the entity it's defined here. I've defined a new entity ID. So this is already the durable functions or durable entities API. We have an entity ID, and the entity name in this case is highscore, and that's a class I've defined myself. You have complete control over it. So we have a highscore class. We have a current value property, which is of type integer. So that's then the value of the points that I can assign to a player. Then it has a method, so we can add points to this current value. We can reset the current value, so we can reset the points of the player. And then here we see that we have defined a new function name of highscore. And this is the syntax that is required by durable entities, so we can actually interact with this highscore entity. So I've also defined this interface, and that's just to make working with this highscore class a bit more type safe. So in this interface, we just have the add and reset methods, because in case of durable entities, you can only have methods in your interface and not the property definitions. So those were the highscore operations. So now let's get back to our client again. So when our function is here, we have our ID to a specific entity, because we are referring to the group of entities. So that's highscore, and we have our player name. So we get back a specific entity. We want to get the score for Margaret or for Grace. So that's what we have here. Then based on if I'm doing a post or a get, if you do a post, I'm going to parse the points I'm providing to an actual value, and then I'm going to signal my entity. And signaling means I'm doing a one-way communication to my entity. So I'm signaling to my entity, and by providing this interface, it knows I can do several operations. So in this case, I'm saying to this specific entity ID, I want to update my points by applying the points using the add method. Because we have the add method and the reset method as part of the highscore operations, You can use the signal entity async like this. So you provide the entity ID and you provide a function which you want to call on the interface. And then I set a response message, which just indicates I've added certain points to that player. So that's for the post. But if I do a get, then I'm doing a different operation. So when doing a post, I'm doing a one-way signal, just add the points to this entity. But if I'm doing a get, I want to read the state from that entity. So then I'm using the read entity state async method. And the entity is of type high score. So that's what I'm using here. But of course I have to give a reference to, okay, which entity do you want to get the state from? So I have to pass in the entity ID again. It has some additional useful methods, this entity response, we do it like this. So it has an entity exists, because I could provide an entity name where there's no entity for. So in case that entity doesn't exist, I can give back a valid response message. Okay, I don't have any data for this player because that player doesn't exist. But if the entity does exist, I return, okay, this player has a high score of so many points. And I can then look into the entity state of my entity, and one of the properties was the current value. So yeah, you do have to get some knowledge, of course, about then the Drupal entity API and Drupal functions API. But then again, it's not too much. You can do one-way communication by signaling, or you can do two-way by just reading the entity state. So let's run this. Drupal entity. So I think I already called this once, and for player Grace and points 50, but let's actually do this for Margaret. Because she doesn't exist yet. We can actually try, because I've now supplied player name Margaret. So let's first do a get and see what the response is. See, there's no data available for Margaret, so she doesn't exist in our storage. And where that storage exactly is, we'll come to that later. So now let's give her 50 points. We're going to give 50 points to Margaret, so let's do this. And then we have added 50 points for player Margaret. So let's do it again. Okay, so now let's do a get, so then we should get back the result that we have now 100 points. Yeah, okay, 100 points. Cool. Okay, if you briefly go back to the function here, so you'll notice that we didn't define any type of storage here, right? So we only have defined a Drupal client attributes and interface here, but we didn't mention any connection strings or storage or what else of that. As I mentioned before when I showed the slide, so Drupal functions works with a storage account. So it will use the storage account by default that Azure Functions is using itself, because Azure Functions also relies on a storage account. So if you're running it in development like this, it reads the connection string from Azure Web Job Storage. So in this case, we are saying use our emulator storage. This development storage is true. So that means we're actually using Drupal functions and Drupal entities against our emulator storage. And the function is still running, so you could still say, okay, maybe this is all kept in memory anyway, but we can actually stop running the function. So that means our in-memory state will be gone, and we can actually start the function again. Yeah, there it goes. So now it's restarting our function. So just to prove that the state is actually kept in the storage when using these Drupal entities. So let's wait until the Azure Functions local runtime is up and running again. Yeah, there we go. So if we again go and fetch the score of Margaret, that should still be 100 points. So let's see if that's the case. Yeah, exactly. Yeah, so the state is actually kept in between different function processes. So now if we sneak peek to our emulator storage, and if you go to persistence demo instances, so I know that under the hood, durable entities is using table storage to persist the state. And as we can see, there is indeed a @HighScore @Grace and @HighScore @Margaret. So there are 2 records in there. This is the one I made earlier, and this is the one I made just now. And if we open that, we can see, yes, we can see in this input field, that actually contains the value of our HighScore. So this is how you can actually see how durable functions and durable entities, how they actually store the data. But like I said, you don't need to know about this, and you don't need to go into this. You can just simply use the durable functions and durable entities API to manage all this. All right. Let's go back to the slides. So I've shown you 4 options of what I call serverless-friendly storage options, and not only serverless-friendly, but also developer-friendly storage options, because each of them can run completely locally on your development machine. All of them scale very well. Of course, one has certain advantages over the other one when it comes to storing large chunks of file or smaller chunks of file if things need to be geo-replicated. And if you really require a more flexible model, for instance, the more actor-based model like durable entities. So do carefully plan and think out your storage options when it comes to serverless. But there are very good options out there. And last but not least, there's also still the SQL server is also there. Also have serverless option nowadays. There's also Azure Data Lake, which is actually more like a storage account layer, but also queryable. So this is definitely not all there is. This is just my favorites, which I can highly recommend if you're just getting started with persistence in serverless solutions. If you go to this link, there will be lots of links to the Azure documentation there of the different storage options. There's also a link to the GitHub repo where the solution is. So if you want to play around with this in your own time, please go ahead. And if you have any questions, you know how to find me. Thanks, everyone.
Voilà, and here we are with Mark live with us for the Q&A. Mark, good evening. How are you?
Hey, good evening. I'm good. Yeah. I hope you enjoyed my very long session. Hope you didn't fall asleep.
The second time I watched it, I still enjoyed it. So thank you for that one.
Cool.
I heard you are still here. You are already in a lockdown in the Netherlands.
Yes, exactly. Yeah. Since yesterday. Yeah,
so
true.
You cannot leave your house anymore?
Well, it's not so strict, but only for essential stuff. So only to go grocery shopping, and that's basically it. So yeah, until half of January. So we have a couple of weeks that we need to stay at home. Yeah. Oh well.
Right. Okay, let's do serverless then. The first thing I wanted to ask you, Mark, is you showed us a lot of local mocking of those storage options. Is that something that Azure already longer provides, or is it a recently new thing?
No. That's already there for quite a while actually, because as soon as Azure Functions came out, they provided that local Azure Functions runtime, so you could run Azure Functions just locally. So no, that's been there, and also the storage emulator was also there. The Cosmos emulator came a bit later, so but yeah. It exists for a while.
It amazes me how many storage options can be mocked locally indeed.
Yeah, I really like it.
Yeah. Then to the questions that appeared in the chat, I saw that someone asked, we saw a lot, the example I think was in C#, and they asked about other runtimes. Are they also, which other runtimes are provided for Azure Functions, and is it as easy as C#?
Right. Yeah. Well, yeah. The other mostly used one is also JavaScript or TypeScript. So that's the second most used one, and also the bindings work for also that language, but also Java itself, and it also works for Python, also for PowerShell.
Oh,
So there are quite some options there. So yeah, except the durable entities one, that's really only C# and JavaScript. But all of the other examples work across many different languages.
yes, I see. Okay. And then let's talk more serverless more in general. I just want to ask you, serverless, the term itself, what does it mean for you and how can
Yeah. The serverless term is I really don't like the term, but it's the one other variation I heard recently was hey, you care about servers less. So
yeah.
that's what I really like. So you don't need to know everything about them. So not all the configuration management or operation management is that important. But you still need to do a lot of. You still need to do a certain amount of operations. You still need to have good monitoring and good tracing in place. So it's not that you can forget a whole area of important work completely.
Yeah.
But there's less focus on it. So that makes sense.
All right, thanks. And then my final question, you showed us a lot of demos, which I want to thank you for because that's something that often is missing from presentations, and here it certainly was there. So thanks for that one. And you used an extension for a REST client in VS Code. What is the name of that extension? Because it looks so nice.
It is actually called REST client.
Oh.
So so yeah, just search for REST client, and then that's the first thing that comes up in VS Code. So yeah.
All right. Okay. Okay. Thanks, Mark. With that, I'm going to let you enjoy your evening or enjoy the next session about Firebase. Mark, thank you very much for being here. See you next time.
Yep. Bye-bye.
Bye. And then we also have with us Renaud in the background. I think Renaud was on mute, but he is now unmuted. Renaud, are you there?
Yes, I'm here. I'm here, Nick.
Aha,
Good evening again. Good evening, everybody.
Awesome. Okay, Renaud, you're going to talk to us about Firebase. The people cannot see you yet. They will see you in a minute. You will do a live presentation and you will share your screen, right?
Yes, indeed.
Okay. Very exciting stuff. Here we go. 3, 2, 1. Opa. Renaud, are you already sharing your screen?
Not for the moment. I will now.
Aha, okay. That is that. Okay.
No problem. Do you see my screen?
Yes, it's there, and I'm going to look. Is it on YouTube too? Yep, it's there. Yep, it's working.
All
Go
right.
ahead.
Okay, so good evening, everyone. Good evening again. First of all, thanks to Nick for the welcome, and thanks to Serverless Days Belgium to host me this evening for this talk, which is about Firebase, a serverless platform and services for application development. Before we start, I'll do a quick intro. So my name is Renaud Tarnek. I'm a Google developer expert for Firebase, a full-stack web-based application developer, architect, and a project manager, and I have more than 20 or 25 years of experience in IT services companies. For like 8 years, I'm a freelance consultant. I have my own company, RTA Consulting, and my service offering is twofold. On one side, I do web application development and exclusively with Firebase, in Firebase, mainly SPAs and PWAs, but I start also working with Flutter. And the second part, the second service offering is interim project management. I help companies and large companies like European institutions or insurance companies. I help them in managing their web application development project, okay, through the all stages of the development lifecycle. I'm very active in the Firebase developers community, and in particular on Stack Overflow, and also on Medium, publishing some article on a regular basis. So, without any further ado, let's dive into Firebase. So in a nutshell, Firebase mobile and web application development platform that will help you as a developer build the application, but as well improve and grow it, okay? More concretely, Firebase offers 18 services, 18 tools of services that will help developers with your web and mobile apps. There are three kinds of tools. We have the developer tools, like database or file storage. We have the app quality tools, like Crashlytics, performance monitoring. And we have the third category is business tools, like Google Analytics or prediction or A/B testing, cloud messaging, and so on. And in this talk this evening, we are going to focus on the main developer tools: Cloud File Store, Cloud Storage, Authentication Service, Cloud Functions, and Hosting. But before we go through each of these services, let's introduce Firebase for a more high-level view. So Firebase is a serverless platform, and it means that all the products or services that Firebase offers are hosted in the cloud. Okay, these products are backend components that are fully maintained and operated by Google in classical serverless mode. But that's not all. In addition, Firebase provides a set of client SDKs for Android, iOS, Flutter, and JavaScript, which will allow to directly interact with these backends from your front end. So there is no need to establish any middleware between your app and the services. You will write code directly, your code will directly interact with the serverless backend components, okay, from your client app. So if we look on the right of the slide, we see the traditional architecture with the middleware in the middle. We have the front end that will interact with the application server or middleware that will expose some APIs. And this middleware, in turn, will interact with the backend tier, either database or file storage services, etc. Okay, that's the traditional architecture. But with Firebase, we don't need any middleware. We will directly interact from the client apps with the services hosted in the backend. Okay, and when I say client apps, again, we can use Firebase with Android, iOS, Flutter, or with web application in JavaScript. And in the rest of the presentation, during the presentation, I will give some demos that will use the JavaScript SDK. So I will give some demo through web applications, but all what I'm going to show is can be done exactly in a similar way with the Android SDK, the iOS SDK, or the Flutter SDK. Okay, so a specific model without any middleware in the middle. We directly interact between the front end and the back end, between the client and the services. But you can also access these backend services exposed or offered by Firebase. You can also access them from a server, from your server. And today, Firebase offers 5 languages, so offer admin SDKs. We call them admin SDKs, and they are available for Node.js, Java, Python, Go, and .NET. So somehow I'm telling you that you can also use Firebase in such a architecture. You know, you could very well have your client app which interact with an application server, and this application server interacts with Firebase services like that. Application, middleware, application server, which interacts with the Firebase services. And I have a customer which use that with a Node.js server, which is hosted on App Engine, and the client directly authenticate by calling directly the Firebase services, and then all the rest of the interaction, getting a list of objects, posting a new object, etc., goes through the Node.js server, which in turn interact with the Firebase backend. Okay, and that can be also very interesting when you want to integrate backend in a legacy environment where you have application servers or even mainframes. And if you want, for example, to take advantage of the real-time capabilities of Firebase, you can very well, from your own server, your legacy environment, you can very well push data to a Firebase database, and the application of your customers, of your users, will connect to Firebase and will take advantage of all the advantages of Firebase, like, for example, the real-time listener. But we are going to see that in a short moment, okay? So that was a very high-level introduction of Firebase and the model of Firebase. Let's dive now in the first service offered for developers, Cloud Firestore, which is a real-time cloud-hosted NoSQL database. So in Cloud Firestore, that data is organized as collections of documents. So for simple data, it's very easy to store this data in documents, which are very similar to JSON. If you have more complex, more hierarchical data, for example, you can easily organize them in sub-collections within documents, and you can have a depth of 100 sub-collections. So more precisely, you see, we can make the analogy with a file, and data is contained by documents, and documents are organized in collections. And what's interesting to note is that for a given collection, you have several documents in the collection, but you don't. One document can have fields that other documents in the collection don't have. Okay, there is no constraint in terms of data model like we can find in the SQL world. Okay, where you have to follow the structure of a table. Here, you can very well save documents with different fields in the same collection. And for each document in a collection, you can have one or more sub-collections in which you will also find some documents. So as I said before, you can organize your data either within one document or in a hierarchical way by using sub-collections which in turn contain documents. And in a database, you can have different collections, as many as you want, okay? Document can contain complex nested objects, like a JavaScript object or JSON object with nodes and subnodes, etc. Okay, they can also contain arrays and arrays of objects. Okay. What's interesting to note that in the NoSQL world, it's you create the database schema based on the queries you want to execute. You don't design your schema based on a normalization. You should not hesitate to denormalize. The idea is to have the data organized in such a way that the queries that are coming from your front end, these queries are as fast and as easy as possible. Okay, so you may denormalize data, meaning that, for example, if you have an information here, let's imagine this collection is a user collection, and here we have a collection of, for example, restaurant review. If here we want to have the name of the user and, for example, his country, we could copy the country of the user from the user collection. We will copy it to the restaurant collection in such a way that when you query the collection, you get all the information on the restaurant review, as well as the needed information on the user. Okay, so you are not going to issue two queries or to make a join. You are going to denormalize your data in such a way that your query are fast and easy. Like I said before, Cloud Firestore offers a very interesting feature, and out of the box, it uses data synchronization to update data on any connected device. Okay, so with the client SDK, you can add a real-time listener to your app, and immediately all the other devices connected to the database will see the updates, so new documents, modifications, deletion. They will immediately see them in their device, on their screen. Okay, so this listener will notify users with a data snapshot whenever the data they are listening to change, and retrieving only the new changes. So that's very interesting, for example, for apps like chats, like real-time dashboards, stock market apps, games, etc. Okay, but you are not obliged to use this mode. Cloud Firestore is also designed to make simple one-time fetch queries and to do that very efficiently. So in Firestore, you can use queries to retrieve either one specific document or all the document in a collection or in a sub-collection, or you can query a collection and you will get all the documents in the collection or sub-collection that match your query parameters. And to build queries, you can include multiple chain filters and you can combine filtering and sorting. Important to note is that queries are shallow. They retrieve data at the document level without the need to retrieve the entire collection. That's the first point. So when you query for a certain set of documents, I don't know, for example, all documents where country equal Belgium, you are not going to get the entire collection in your client. Obviously, you are going to get only the documents corresponding to your query. That's the first point. And the second point is that you are not going to get the nested sub-collections. If you want to get the sub-collection, you will have to issue a new query dedicated to those sub-collections. Okay, and queries always return whole documents, so you cannot query and get back only some fields. To be really precise, this is possible with the REST API because Firestore offers also a REST API, and actually the client SDKs are a layer above the REST API. Okay, so with the REST API, you can get only a subset of the field, but you using the REST API may be interesting, but you will lose all the flexibility and the ease of use of the client SDKs. And what's very important to note, because it's why Firestore is extremely scalable and performant, is that the performance of the query is proportional to the size of the result set, not to the data set size. Okay, so you may have billions of documents in your Firestore database. If your query results in 5 documents, you will get them immediately. It will not make any difference if there is 5 documents or 1 billion documents in the database. The performance, the response time is directly proportional to the size of the result set. Okay, so due to the fact that it's a NoSQL database, there are some limitations. Okay, in particular due to the way the indexing works. For example, it's not possible to directly make OR queries, or it's not possible to do some aggregation queries, or it's not possible to query for non-existing values. But most of the case, there are workarounds, there are some kind of recipes, I would say, that you can, by organizing your data model a little bit different, or by duplicating data in a specific way, you can, in most cases, you can bypass, you can have some workarounds around those limitations. So, as I said, one main advantage of Cloud Firestore is the fact that it's highly scalable. And so Cloud Firestore is a multi-region solution, okay, that will scale automatically. And when I speak about region, I mean Google Cloud Platform regions. And Firestore will house your data across multiple data centers in distinct regions that will ensure a global scalability and a strong reliability. It's available either in regional or multi-regional configurations around the world. And in Europe, we have data centers in Belgium, in the Netherlands, in London, Frankfurt, Zurich, and they are opening more and more over the time. It scales completely automatically. Currently, there are limits which are around 1 million concurrent collections, 1 million, and around 10,000 writes per second. And so, like I said, Firestore is technically a Google Cloud product. Okay, so you can very well use Firestore without using Firebase. Okay, but what does Firebase? Among others, Firebase adds the SDK to use Firestore in mobile or web apps and to make direct data access possible. And as we said, without any middleware. Okay, so like I said, there are some limits. Another one is the maximum write rate to a document of 1 write per second. So, for example, here, a workaround, if your application needs to a write rate that is higher than 1 per second, what you can do, you can distribute the load on multiple documents. Okay, so you have to change your data model, your architecture, but it's one solution. Like I said, the maximum writes per second at the database level is 10,000 per second. And if you want to use a transaction, you will be limited to 500 writes within one transaction. Another very interesting feature, which is as well as out of the box, is the offline mode. So Firestore supports offline data persistent out of the box. This feature will cache the copy of the Firestore data on your device, and in such a way that your application can access the data when the device is offline. And here we are not only speaking about the iOS, Android SDK, but it's also the case for the web SDK. So for web application, you can also activate the offline data persistent. So you can read, write, listen to, and query the cache data. And if you write, the data is stored locally on your device. And when the device comes back online, Firestore will synchronize any local change made by your app to the Firestore backend. Okay? And again, this is out of the box. You don't need to do any change. You just need to activate it. But actually, on iOS and on Android, it's activated by default. And on the web, you just have to call a specific function to activate it, specific method to activate it. Okay, so that was Cloud Firestore in a nutshell. Let's have a little demo, a small demo. So what I'm going to do, I'm going to open two different browsers, one here and another one here. And I'm going to show you a very simple messaging app. So I will log in as two different users. Hopla. Is it correct? No. I should have chosen a shorter password. So I log on one side as Renaud, and on the other side, I log as Natasha. And I'm going to post messages. Okay, so hello, Natasha. And you see in real time, what do I see on the other browser? So it's totally disconnected. On one side is Safari, on the other side it's Firefox. I see the same message appearing. Okay, I can continue here. And here again, being Natasha. Okay, and you see, I see the different posts, and what I'm doing here, and I will show you the query. Again, one message. I only query for the 5 messages. And so if I add a new one, then I will only see the last 5 ones. Okay? But what I can show you now, before showing you the queries, the code, I can go to the console, to the Firebase console. So on the left side, on the vertical menu, I see the different services to build an application. Okay, the authentication service that we are going to detail later on, the Cloud Firestore time database, which is the original database of Firebase, the cloud storage service, the hosting, the cloud function, and the machine learning service. And if I refresh here the console, I see a new collection called messages, you see, and in this collection I have 6 messages. I have created 6 messages with an ID that was auto-generated, and here are the fields within the document. Okay, and let's look at what's happening if I create another document here. You see here immediately in the console, I see the new document coming. And if I delete the document, I will also see it in console. Okay, and if I delete the entire collection, so here I have to confirm. Immediately I get the no message So no message, message, okay? And so just to show you how the real-time listener is working, okay? So let's look now at how easy it was to set up such a real-time listener and to how easy it was to create documents from the front end. So again, here I'm showing you an example in the JavaScript SDK, but it's very, very similar with the Android and iOS SDKs. So to write to the database, it's an asynchronous method. So I use an async function. Okay, I get the user ID because I want to display the email of the author. So actually I should have called that user email. I get the user email through the Firebase authentication service. I have a property which is current user, and this property has a sub-property which is email. So I put that in this variable, and then I call Firebase FileStore, the FileStore services, the collection called messages, and to this collection I call the asynchronous add method, and I pass to this method a JavaScript object with the message, okay, that I get from the form, the author email, and I use a specific Sentinel value, which is a server timestamp, which will be transformed at the moment I write to the server. This Sentinel value, this token, if you want, will be modified by the time of the server. Okay, so this is the asynchronous write. And then how do I set a listener? I call Firebase, the FileStore services. I want to set my listener on the messages collection. Okay, so I could stop here, and from here I could directly call the onSnapshot method, and then I will receive all the documents in the messages collection. But what I want to display, I want to display first only the last 5 ones, so I limit to 5 documents, and to have the last one, I have to order this query. I order by creation date in descending mode, and the result is what we have seen. The last message appears at the top, and as soon as I have more than 5 messages, the older ones just disappear from the front end because the query does not return them anymore. Okay, and if I wanted to instead of setting a listener, I wanted to read one document in a kind of get and forget mode. Okay, I get the document, or I get the content of a collection, and then I forget it. I will do like that. I will declare a document reference, so Firebase, FileStore, the collection cities, here it's an example, and the doc with the ID BXL. And then from this reference, I call again an asynchronous function, which is a get method. And since the get method returns a promise, a JavaScript promise, I use the then method to deal with the result, to treat the result. And here, what I do here, I just check if the document I have queried exists, and if it exists, I will console log the data contained by this document. Okay, as simple as that. So that was Cloud FileStore. Let's now move to Cloud Storage, which is the service that offers a massively scalable file storage. So Cloud Storage for Firebase is a powerful, simple, and cost-effective object storage service. It is built for app developers who need to store and serve user-generated content like photos, videos, or any business document, PDF, Word, whatever. You will, as a developer, you will again use the Firebase SDK for cloud storage. You will use it to upload and download files directly from your client. Again, still the same model. And I'm not going to show any code examples, but it's as simple as what we have seen with FileStore. Okay, Firebase SDK for cloud storage will perform the upload and the download regardless of the network quality. So these uploads and downloads are what we call robust. It means that they will restart where they stopped, saving your user times and bandwidth. So this may be interesting in countries where the quality of the mobile network is not at a very high level. So automatically, the SDK will resume uploads and downloads that were stopped due to connectivity problems. Okay, and again, exactly like FileStore, Cloud Storage is technically a Google Cloud product, and it is built for exabyte scale. I even don't know what does it mean. I mean, I could not write, the exposant, or I could not tell you how many zeros. But in other words, it's the exact same infrastructure that powers Spotify or Google Photo. Okay, so you can imagine the scalability and the power and of file storage. It stores your file in a Google Cloud Storage in a storage bucket. Okay, so you can have many buckets in one Firebase or one Google Cloud Platform project. You can have several buckets, and it will make those files accessible through both Firebase and Google Cloud. Okay, so you could very well implement an application or a process in Google Cloud Platform and access the files that you store through your Firebase project and through your client connected to your Firebase project. Okay, again, it's a product of Google Cloud, so you can very well share the services offered by the two platforms. And if I have time, I will show an example at the end. For example, you can very well use the Google Cloud APIs like Google Translate or Google Vision to read and to consume the files that you upload to cloud storage, and you can very well use these APIs to read those files and to do their job. Okay, so what's important to note is that there are some limitations to the client libraries. Okay, they cannot, for example, create a new bucket. This is something that is called as a privilege operation, and that is reserved to administrators. And you can only do it through the command line interface or through the server, through the admin SDKs running from a privileged environment. So what does it mean, a privileged environment? It means your own server or Cloud Functions, which is another service that we are going to detail later on. Okay, so you cannot, for example, you cannot create a new bucket from a client application. In other words, there are some action, mainly the admin actions, that are not authorized for the client SDKs. What's also important to understand in cloud storage is that there are not actually any folder. There is no concept of folder. You can define paths which look like they are organized as folders. So here I give an example. I have a slash here. So the console will show that as a folder, large picture, and within this folder, you'll have the big image.jpg. Okay, so it's just a way to ease your life when you look at the cloud storage console and you navigate within the different files that are there. But in reality, there is no concept of folder. Okay, but again, you can mimic the presence of folders by using slash. Also very important to note, and it's the same for FileStore, you can integrate cloud storage with Firebase authentication to provide a simple and intuitive authentication for developers and to limit who can access to files in cloud storage. Okay, and you can also use the declarative security model to allow access based on file name, on size, content type, or even based on metadata. And we will give more info in few minutes. So that was cloud storage, a massive file storage service offered by Firebase. The third service we are going to look at is authentication. So user login and identity, easy sign-in with any platform. So Firebase authentication provides backend services and easy-to-use SDK to authenticate user to your app. It supports a lot of identity providers. First, the classical username password or email password, phone numbers, and a set of popular federated identity providers like Google, Facebook, Twitter, GitHub, Play Games, Game Center, Apple, Yahoo, Microsoft. By phone, like I said, you can also use an anonymous authentication. What is it, anonymous authentication? It's the possibility to if your user at first use, at the beginning, they don't want to authenticate or to log in or to create an account in your application, they can try the application and they will try it as an anonymous user. And if after that they decide to create an account, we will be able to link the content they have created as an anonymous user. We will be able to link it to their new account. Okay, and very important, we can use any custom authentication system. I have a slide dedicated to that later on. Okay, so a very large offer of identity providers, which is quite interesting, and it covers, I will say, most of the needs of modern apps. So, like we said, it integrates tightly with other Firebase services, Cloud File Store, Cloud Storage, but also the real-time database, with the use of security rules. So, on one hand, you use Firebase authentication as the authentication part. Okay, so what does do the authentication part? It validates the user's credential, such as user ID password, to verify their identity. So authentication check, and that's the case for any system, any application. The authentication will check whether you are what you say you are. Okay, using your credentials. So in Firebase, for the authentication process, we are going to use Firebase Authentication Service. And then we have the second part of the security solution, the security platform. It's the authorization part. And the authorization part will determine whether the authenticated user has access to the particular resources. So this is, in Firebase, this is ensured by security rules. And security rules will verify in the backend the user's access rights to grant him or her access to given resources. And you have the possibility to implement a role-based access control strategy. And for that, you will use custom claims. And custom claims are custom attributes on user accounts. So they are actually on the token, on the JWT tokens. And those attributes are accessible via the users, via the JWT, via the JOT, via the authentication tokens. And the security rules can access these custom claims, and based on these custom claims, for example, if you have the custom claims that you are administrator or the custom claims that you are editor, then the security rule will be able to read this custom claim, and depending on the different custom claims you have, will open or not access to a specific part of file store or a specific part of cloud storage. Okay, so like it is said here, those custom claims can give users different level of access, different roles, which are enforced in the application security rules. So again, in the backend. Okay, so when the client queries the backend file store, file storage, when the client query to either read or write, the security rules are enforced, and the security rules will check if the user has the custom claims, if the user is correctly authenticated, etc. From a developer perspective, Firebase proposes a library called Firebase UI, which is a set of, it's not only one library, it's a set of open source libraries for Android, iOS, web, as well as Flutter, which is built on top of the Firebase authentication SDKs, and that will allow you to easily integrate user interface flows for use in your app. Okay, so it's a kind of a framework of pre-developed user interface element to log in, log out, to recover password, etc., etc. And you can take them and you can very easily integrate them in your own application. But on the other hand, using the SDK, the Firebase Authentication SDK, is really, really easy. In about 10 lines of code, you set up an entire authentication system, including password reset or other complex cases, okay, like accounts merging, etc. I mean, login, creating a new account is calling one method, it's one line, okay? You pass an email and a password, and the account is created, and logging in is also one line. You call one method, and you just pass username and password, okay? So very, very easy. The authentication service leverage industry standards, okay, like OAuth or OpenID Connect. So it can be very easily integrated with your custom backend. And also, Firebase, if needed, gives you complete control over the authentication by allowing you to authenticate users or devices using secure JWTs, JSON Web Tokens. And so you will generate those tokens on your own server. You will pass them back to the client device. And then from the client device, you will be able to use them from the client to authenticate via a specific method, which is sign in with custom token. So not only you have a rich set of identity provider, like we've seen before, to rapidly integrate a top security solution into your application. But if you need, for example, to have a single sign-on, if you need to use your company LDAP or any proprietary authentication system, you can very well do that with Firebase. All the methods are there and to do that. Okay. The last slide for this part on Firebase authentication is about security rule. So like we said before, security rules will leverage an extensible, flexible configuration language. So it's a specific language which will define what data your user can access for Cloud Firestore and cloud storage. Okay, so it's the authorization part. And it works by matching a pattern against database paths and then applying custom conditions to allow access to data at those paths. So all rules across Firebase products have a path matching component. So for example, match collection messages. Okay, and then together with this path, we have a conditional statement which will allow or not to read or write data at this path. Okay, so we have the path. So in the case of Firestore, for example, the collection message, or in case of cloud storage, the folder images, and we will allow or not different methods like read, write, modify, delete, with certain conditions. Okay, for example, the user is authenticated, the user has his email verified, the user has a custom claim with the name of my company, the user can delete a document with a field with value archived, etc., etc. Okay, it's a very flexible configuration language, a bit similar to JavaScript. So that was the authentication service. Let's now dive into an important service, Cloud Functions, which are a serverless event-driven backend. So a serverless backend, Cloud Functions, a serverless backend. It's a serverless execution environment, and then your code will execute in a fully managed environment as any serverless platform. Okay, there is no need to provision any infrastructure or worry about managing and configuring any servers, like all the other Firebase services. The provisioning of resource will happen automatically in response to events. We will see that. And a Cloud Function from few invocations a day to many millions of invocations without any action from you. And what's very important is that you are only billed for your function's execution time, okay? And you pay nothing when your function is idle. So where is Cloud Functions? Cloud Function, again, is a serverless backend. So if you remember this diagram, this picture we saw before, we have the client app, which through the client SDKs interact with the Firebase services. And typically, we have some business logic in the client app, okay? But with Cloud Functions, we can also have business logic in the backend, okay? And this is very interesting for many reasons that we are going to see in the next slides. So Cloud Function, a serverless backend, and an event-driven backend. Like I said, Cloud Function for Firebase will let you automatically run backend code in response to events triggered either by Firebase services or by HTTPS requests or by Google Cloud Scheduler. So I divide those triggers in two categories. We have the background triggers that are triggers that occurs in the backend services, backend file-based services. So we have triggers for Cloud File Store, for real-time database, for cloud storage, for the authentication, for the remote config, for the test lab, for Google Analytics, and for Cloud Pub Sub. Cloud Pub Sub is a messaging system, the messaging system offered by Google Cloud Platform. And on the other hand, we have the direct triggers. We can trigger, start a cloud function by calling an HTTP endpoint. We can also directly trigger a cloud function from an app, from a client app. Okay, so it's called callable cloud function, and actually they encapsulate an HTTP cloud function, but they ease the way you authenticate, etc. And the third direct trigger is a schedule trigger, so you can schedule a cloud function to run at a regular interval, okay, exactly like a cron job. And for that, the platform will combine Cloud Pub Sub topic with a Google Cloud Scheduler. So let's look in more details. What are the capabilities of Cloud Function? So I'm going to a little bit to repeat what I've said, but this is the full picture. So on the left part of the slide, we have all the triggers. Okay, so like we said, you can trigger a Cloud Function through an HTTP request from your client app with an event occurring in one of the file-based services by publishing a PubSub message or through a scheduler. And when you have triggered the Cloud Function, what can a Cloud Function do? A Cloud Function can interact with the file-based services. So, for example, it can write to the file store database. It can read cloud storage file. It can create a new user. It can delete a document, etc. It can interact, very interesting, it can interact with APIs and services. So first, the Google Cloud APIs, like I said, the Google Translate, Google Vision, etc. But it can also publish PubSub messages, but it can also interact with other APIs exposed by other providers. In other words, microservices. Typically, the famous microservices are, for example, SendGrid and Mailgun to send email, Stripe to make payment. So you can very well, from a Cloud Function, interact with those services to send an email, to make a payment, etc. But you can also call any URL or REST API exposed on the web. You can, for example, call the REST API of Facebook, of GitHub, of Twitter, etc., etc. Okay? So remember, again, you are in the backend. Okay? Some few examples of background triggers within the file-based services. So if we look at Cloud File Store, the NoSQL database, we can start a cloud function when we create a document, when we update a document, when we delete, or when we do one of these three actions. So the on-write trigger encompasses or joins contains the three other ones. In cloud storage, we can trigger a cloud function when we create a new object, when we delete an object, when we archive an object, if your bucket has the versioning option, or if we update the metadata of an object. When I say an object, I mean a file. In the authentication service, we can trigger a cloud function when we create a user or when we delete a user. Okay. And depending on the trigger type, the cloud function will expose a number of properties of the entities that trigger the function. So obviously, if you trigger a cloud function when you create a new document, you obviously have access to the fields of this document, to the field, to the name of the parent collection, to the date and time, the time when the document was created, etc. Okay, and this is, for example, for the time of the function execution. You will also have another parameter, which is context, which will provide information about the function's execution, a unique ID, for example, etc. Okay, so that was examples of background triggering. But you could ask me, okay, but for what, when, and for what I will use cloud functions. So in the next 2 slides, I will list quite rapidly some examples of use case of cloud function. One very classical use case is to synchronize database nodes or database document. You remember at the beginning, I said that it's quite classical to denormalize your data. One of the best way to maintain this denormalization or to maintain different parts of your database in sync is to use a cloud function that will be triggered each time you create or each time you update or delete a document. The cloud function will update the other parts in the application where the data is denormalized. Also, I told you that it's not possible to do some aggregation queries. How do we do if we want to have some aggregated figures? We are not going to, for example, query one entire collection to count the number of documents. Okay, it can be very costly if you have a lot of documents in this collection. The solution in the NoSQL world and in Firebase is to maintain some counters. And for that, the best candidate is to use cloud functions. Again, the cloud function will be triggered each time you create a new document or you delete and will increment or decrement the counter. Cloud function is also very good as the glue between several Firebase services. A very common approach is when you create a user, if you want to add some extra information about the user, his company name, the URL of a picture, etc., etc. So what you will do, you will store this extra information in a Firestore document, and you can use a cloud function to create. You will send this information to a cloud function that will first create a user in the authentication service, and secondly, we will create the Firestore document with this extra information. Okay. Very interesting also, it's when you have either a complex business logic that can only be implemented in a backend and not in client for different reasons. For example, if you need to interact with a service or with a Google Cloud API, obviously you cannot do that directly in the backend. So you have to do that you cannot do that in the front end, sorry. So you use cloud function to do that in the backend. If you have a proprietary business logic, okay, which is, for example, the asset of your company, and you don't want that this code is exposed in an application, because in any application, either mobile or web application, it's not very difficult to reverse engineering the application. So the users could relatively easily reverse engineer your code and get your code. And in some cases, this code is your secret sauce, is an asset of your company. And so instead of implementing it in the front end, you implement it in a cloud function. And the cloud function is not accessible by the end users. The end users can only interact with the cloud function exactly like an API. Okay. Also, an interesting use is to implement a business logic only once instead of implementing it in each client platform. You can use cloud function if you want also to execute intensive tasks, okay? That you don't want your front end, your application being frozen, so you delegate the heavy work to a cloud function, knowing that there is a limit of 9 minutes for a cloud function execution. If you need to do some work that takes some processing that takes more than 9 minutes, then you have to choose another solution. You can also generate dynamic content, a bit like in the last years about like JSPs, okay, or ASPs in the 2000, where you generate HTML content on the fly. So you will do that with the cloud function, and you will use Firebase hosting to expose this generated dynamic content. You can use cloud function to send a notification to your app. You can integrate with microservices. I've already detailed that. You can also expose a cloud function as a webhook of a microservice. Okay, for example, with SendGrid, when you send an email, you can ask SendGrid to inform you back on the fact that the recipient has opened or not, or has deleted the email. And for that, SendGrid will ask you to expose a REST API to be called, that the SendGrid service will call with this information. And to do that, in the Firebase ecosystem, you will use a cloud function and you will expose an HTTPS cloud function, and which will be called by the service. You can use cloud function also to override as a workaround on some client SDK's limitation, like listing sub-collection is not possible in the client SDK, or using queries in transaction is not possible. So you can, as a workaround, you can use cloud function. You can use cloud function to totally bypass security rules. So since you are in a controlled environment, you are the only one to control this environment, the admin SDK totally bypass the security rules. Okay, so it can be very interesting because for the external user, you put in place a set of security rules, but you, with the code that you have in your backend, you don't have to worry about the security rules. You can just read and write without any constraint. Like I said before, a classical use of cloud function is to manage users, to create, deactivate, delete, to send password, reset, etc. And last but not least, we spoke about custom claims. The most classical way to set custom claims is through a cloud function. And again, this setting a custom claim to a specific user can only be done in the backend, so through cloud function or through one of your servers. But you cannot do that from the front end because you could open a breach, a security breach. That was cloud function, a very important part of the Firebase platform. The next one is hosting. It's a global web hosting solution. So here, obviously, it's not a service that is used by Android and iOS. It's a service which is used for web application. Firebase hosting will provides a fast and secure hosting for your web app, static and dynamic content, as well as for microservices. So hosting supports all kinds of content for hosting, like static files like HTML, CSS, JS file, up to Express.js microservices or APIs. So it's a perfect solution for a single page application, for a progressive web app, or simply for a simple app landing page. Okay, each file that you upload will be cached on SSDs at CDN edge, so content delivery network edge, all around the world. So again, it's a Google infrastructure. So as soon as you push a new file to the hosting service, in few minutes, this file will be populated, will be distributed all around the world in the Google content delivery network edges. No matter where your users are, the content will be delivered very fast. What's also interesting is that obviously all the content is served over SSL, and Firebase will automatically provision SSL certificates for all your domain. Okay, and that's for free. So if you want to expose your own website or your own blog, which is made of few HTML pages, you can very well use Firebase hosting, and you will get an HTTPS certificate immediately for no cost. So from a developer perspective, you will use the command line interface to deploy your files from your local directories on your computer to the hosting server. You have some alternatives. You can use the REST API, or you can integrate with various web-based IDs like StackBlitz or Glitch. Like I said, Firebase hosting integrates with serverless computing options like Cloud Functions or Cloud Run. And this is a way to host microservices by directing the HTTP requests which are made towards the hosting service to direct this HTTP request to trigger your Cloud Function or your containerized app that run in a managed and secure environment. So I don't know if I'm very clear, but when here in the Cloud Functions, I was mentioning the possibility to generate dynamic content served through Firebase hosting. This is how we do with Firebase hosting. So we redirect queries to Firebase hosting. We redirect them either to a Cloud Function or to an app hosted on Cloud Run. Okay, And for serving your content, Firebase offers several domain and subdomain options. By default, your project is hosted on either the web.app domain or the firebaseapp.com domain. These two sites serve the same deployed content and configuration, but you can connect your own domain to a Firebase hosted site. Okay, so if I go back to where it is, the app I shown you during the demo, you see here at the top of, the URL is made of the ID of my Firebase project, and the extension, the rest of the URL, the domain is .web.app. And if I look at, you see at if I look at the name of my project, you find here the project ID that you saw in the URL. Okay. So what time is it? We are close to the hour. What I can propose you, so we have reached the end of the presentation. Okay, so we have looked at FileStore, the NoSQL database. We have looked at cloud storage, the file storage solution. We have looked at authentication, the authentication service, at Cloud Function, the serverless event-driven backend, and we've just finished looking at the hosting solution. I have what I think an interesting demo. I don't know if we have enough time. Maybe Nick, can you please confirm if I can go through this, if it's time for Q&A?
I would love to see a demo.
Okay, so let's go. So this is a demo of a small web app that is called Travel Translator. And this app actually will translate any text that you take if you take a picture of a text, it will translate this text in English. So you can open this app in your browser. Okay, I will let this slide for the next 20 seconds, and then I will do the demo in my browser. But you can very well use your smartphone, for example, to open the app either through the URL or by scanning the QR code, and you can try it. Just open a book in any language, preferably not English, because it's going to translate into English. So, and take a picture and look at the result. And in a few seconds, I will go through an article which details the code of this application. And what's interesting is that it's no more than 25 lines. So travel-translator-web.app. And I will now demonstrate it. Here it is. So you see the app, I'm in a responsive mode to simulate a smartphone. So I click on this button. If you use your smartphone, you will be able to take a picture, and I will select an image here, which is a text in Italian. So the Cloud Function will start. So we have to wait a little bit. This is the famous call start. The first time you start a Cloud Function, it takes a little bit of time, but after it the response time is much better. So you see here, the application has detected that the original language was Italian, and it gives me back the translation. Okay, so I don't know if you have tried it on your side, but what I propose now is to detail the architecture and the code of this application. And I have written an article in the Firebase publication on Medium. I have written an article which is titled "How to Create an Image Translation Web App in 25 Lines of Code." And what we are going here is that I'm going directly to explain you the way this application works. And if you want later on, you can go through the article. The URL is in the slide. So let's first look at the different components and how this application works. So here we have the web application, okay? And from the web application, we are going to take a picture or select an image. And the first thing we are going to do, we are going to upload this image to cloud storage, okay? So remember, cloud storage is the file storage system offered by Firebase. So we upload the image. Then what we do, we set a listener, exactly similar listeners than the one you've seen in the first demo. We set a listener on Cloud Firestore on a specific document in Cloud Firestore. But what's important to note here is that this document does not exist at this moment. But we can set a listener, and the listener will be triggered when the document will be created. And actually, the listener is listening to a document which has an ID which corresponds to the ID of the file that we have uploaded in such a way that we can link the two elements. Okay, so I upload the file. What's happened then? A cloud function is listening to the cloud storage bucket, and as soon as the file is created, the cloud function is triggered. The cloud function reads the files and pass the URL of the file or the address of the file to Cloud Vision API, a Google Cloud Platform API. The Cloud Vision API will do an OCR, an optical character recognition of the picture. Okay, so in the case of Italian, it will send me back the Italian text in text format. Okay, so it will OCR the image and sends back to the Cloud function the text image, the text of the image. Cloud function at this moment writes to the to be created Firestore document. It writes the text as well as the original language, so Italian, Dutch, whatever. Okay, the Cloud Vision API returns the text plus the original language, and we use these two values and we create a document in Cloud Firestore. At this moment, we have what is called the Firebase extension. I will give a little bit more details, but actually Firebase extension is a pre-packaged cloud function that answer to specific or to classical use cases, like translating a content or generating a thumbnail for an image or sending an email or executing a payment through Stripe. But what's interesting to note is that actually behind an extension, you always find a cloud function. So what this Firebase extension is doing, actually, it calls the cloud, the Google Cloud Translate API in order to translate the text that was written by Cloud Vision API. So we have the text in Italian. The Firebase extension is listening to the Cloud Firestore collection, the Cloud Firestore document. As soon as the document is created, the extension takes the text in Italian and translates it into English and writes it back to the Cloud Firestore document. And at this moment, the listener will detect that the translation has been written to the Cloud Firestore document, and it will shows it in the app. Okay, so we will go for each part. We will look at the code, and I will show you that in no more than 25 lines, a total of 25 lines, we have an application that can do that. And it's a very good example on how you can mix and match the different services offered by Firebase. Okay, we have here the file storage, the NoSQL database, and we have two cloud functions because this one is equivalent to a cloud function. We have two cloud functions that makes the glue between those service and an external API, the Google Cloud Vision API, and actually also the Translate API. Okay, so let's dive into the code. The first thing I will do before diving is to show you the extension. So I open the Firebase website, and I will go to the home page, and I will go at the bottom just to show you the extensions. Why I don't find them? Apparently it has changed. I will go to products. Where it? Here it is. No. Yeah, here. So these are the extensions. I will display all the extensions. Sorry, the documentation has changed in the last day, so I was a bit puzzled. So here we are on the pages for the Firebase extension. And you see, we have a set of extension. Like I said, you can, with an extension, is a pre-packaged solution, okay, that how to say that it's a prepackaged solution developed by Firebase, okay? So you don't have to reinvent the wheel for some of the most classical needs for an application, okay? So for example, if you need to resize images, if you want to trigger an email, if you want to delete user data, very interesting for GDPR, if you want to increment a counter, if you want to send invoice using Stripe, if you want to translate text, this one that I'm using, if you want to shorten URL, etc. Okay, you can use an extension. So let's go back now to the article and let's start by the easiest part is how we configure this extension. So it's, like I said, it's a translate text extension. So we configure the extension, we give the location, the data center on which the extension is going to run. Here it's in US Central. We configure it to translate into English, but we could very well have several languages, okay? We define the collection that is to which the extension is listening. So each time a new document is created in the OCR translation collection in FileStore, this extension will be triggered and will read the content which is in the input field and will write back the result of the translation in the field that is called translated. Okay, so each time I create a document in OCR translation with some text in the input field, the extension is triggered and writes back the English translation in the field translated. Okay, so that was for the translation. Then let's look at the web application. So remember, the web application is here. Okay, so let's look at how do we do to first upload the file to cloud storage, and secondly, to set up the listener to this document and to display the result of the whole process. So it's a very simple web page with some JavaScript, okay? So I have the configuration for my Firebase project. I initialize my application, and then I have a function that handles the upload of a file, okay? So I get the file name, I declare some metadata for the file name, and I create a new document in the OCR translation collection. So in FileStore, in the database, I create, sorry, excuse me, I have to repeat, I was not precise enough. I don't create the document here, I just call the doc method, which actually gives me back the reference of a document. But this document does not exist yet, but I have this ID, I have his ID, his reference in the database. And I use this reference to derive the ID of the document, and I use this ID as the file name of the image I'm going to upload to cloud storage. Okay, so when I have that, I create a file reference, a cloud storage reference. So I call Firebase storage, the ref method, and I pass the path of my file. Okay, so sorry if I was not perfectly exact here. So in FileStore, I generate a document reference. I use the ID of this document reference to name the file that I'm going to upload. Okay, with this file name, I create a file reference for cloud storage made by a first part which is corresponding to a folder, and the second part which is the name itself and which is derived from the FileStore document ID. Then on this file reference, I call the put method, which is an asynchronous method. Then I use a then method to, when the promise returned by the put method is resolved, I know that the file was correctly uploaded to file storage. And at this moment, I set a listener using doc reference, which is the reference of the FileStore document, and I call the onSnapshot method, and I set a listener to this document. At this moment, this document does not exist, but I set the listener, and what I do in this listener, if the document exists, and if this document has a field name translated, at this moment, I write to my user interface, I write the translated English text, and I write the original language. I hope I was clear and not too, it was not too confusing. Okay, so that's in the web app. So if we go back here, what I do, I upload a file, I create the reference of a document here to get an ID. I use this ID to push the file in cloud storage, and I set up the listener, which is listening to this document. But for the moment, there is no document. Then it's the turn of the cloud function to enter into the swing. And let's look at the code of the cloud function, where it is, here. So the cloud function is a cloud function that is triggered when an object is created in the storage services. Okay, so functions.storage.object on finalize. It means that the object is uploaded. From this object, I get the file path, okay, the name of the object, the file path in the bucket, and I get the content type. And then I will derive from the name of the file, I will derive the ID of the file store document. You remember, I use the same ID to generate the reference to the file store document and to name my object. So here in the cloud function, I extract the document ID, and then I first check that the content type starts with image. If the user has uploaded something else than an image, I just write an error and I stop the cloud function. If it's an image, I will create a new Vision API client, more precisely an image annotator client. And then I will, on this client, I will call the text detection image. And you see here, I pass to this method text detection, I pass the internal address in file storage, the address of the image to be treated, to be processed by the Cloud Vision API. So GS : / the name of my object, the name of the bucket / the name of the object. This is an asynchronous method, so I use async await, and I get an array which contains the results, and I parse this array. I get the text annotation and the input. So from the result, I take the property text annotations. This gives me a variable called detections, and from this variable, which is an array, I get first the description, which is actually the translated language, the language resulting from the optical character recognition, and I get the local, which is the original language. So at this moment, the cloud function has executed the optical character recognition of the image and sends me back. I have the text in original language, in my demo, in Italian. And with this text, like I explained before, I will write to FileStore in the OCR translation collection a document with the ID that I have calculated above, which corresponds to the file name. And for that, I use the set method on the document, and I pass to the set method an object made from first the Italian, first the Italian language, sorry, yes, the original language, so the fact that it is Italian, and the path of the image. Okay, so three fields. And then I stop the cloud function. Okay, so that was the description of all this process here. The cloud function sees that there is detects that there is a new document, a new file created in cloud storage, calls the Cloud Vision API to do the OCR, get back the language, the text contained by the image, which is in Italian, and the fact that it's in Italian language, the Cloud Function writes to the file store database in the corresponding collection. At this moment, the trigger doesn't see any translated field, okay? So it doesn't do anything. The application is still waiting. But at this moment, the Firebase extension sees that detects that there is a new document created in the file store collection and immediately translates from Italian to English and writes back the English translation in this document. And at this moment, the trigger, the listener, is activated and display the result in the front end in the application. That's it. That's the explanation. I hope I was clear enough. It's quite complex to explain. So it's, in my opinion, it's a very good example on how you orchestrate with the different triggers and the different listener, how you orchestrate all this process, one after the other, and how Cloud Function is doing the glue in the middle, the kind of control tower, taking information here and pushing it there and getting back the result, and that's it. I hope you enjoy the talk, and I would be happy to answer any question.
Hi, Renaud. Can you hear me?
Yes, I do.
You can. I think people can hear me, but they cannot see me on screen. Is that right? But that's okay. As long as they can see you. Renaud, thank you for the well explanation of Firebase and also the example. I think I saw in the example that people can check out the code on GitHub. Is it correct?
Yes, indeed.
The link is in the article.
Yes, exactly. Let me share again. At the bottom, you have the information, and you have the link. You have everything in GitHub, where it is.
Okay.
I don't know, but you have the link to GitHub. Yeah, indeed.
Okay. And then you also showed us when you showed us the demo application where people were chatting with each other, you were sending messages back and forth. And that is by listening on changes on the data. You listen for changes, and then real time get notified if a change appears. Is that how it works?
Yeah, exactly. Exactly what I've shown here. Okay. So I've set up a listener in the app as simple as like I've just shown in the translator application uses exactly the same way by setting a listener on a specific collection. It's a query, and I use a on snapshot method, and then immediately as soon as I do that, the application is listening to the backend, and each time there is a change, the listener will be triggered.
Yes. Okay. And I'm back on the screen. By the way, I just put off my camera. My fault.
You have a very nice hat. I'm
totally back in the Christmas spirit. And I also have these nice ponytails now. To go further on the real-time update, I think Firebase also supports something like push notifications. Is that right?
Yes. That's totally right. But it's
the same thing, or it's different.
It's totally different. It's a service that I didn't detail. It's a service that allows you to push notifications to devices. Okay. If I go to the documentation, I don't know if now you see my screen. No, it's not this one.
We cannot see. Yeah, that's right. People cannot see the screen anymore because we're on the next screen now.
Let me. I will go in the doc. I will just tell you the exact name. It's cloud messaging. Okay.
Mm-hmm.
Cloud messaging. So through cloud messaging, you are able to push notifications to the client. So either iOS, Android, but even web. Okay.
Okay, and that is used. But that is not to do a chat, for example. That is just for a small one-time notification.
Exactly. It's the classical notifications that you see appearing at the top of on your smartphone.
Yes,
Okay.
indeed. Okay. Then I've reached the end of my questions, and with that also the end of the evening. Renaud, thank you for this very good explanation of Firebase. I think people really had a lot on it. Because someone actually mentioned that next to your blog, they also provided a YouTube channel, Fireship. Do you know it? Is it something that people should check out?
Fireship. It rings a bell. It rings a bell. Wait, let me check.
I just got a message from someone here. People should also look here.
Fireship. Let me. Yeah, so Fireship is actually the YouTube channel of one of my GDE colleague, Google Developer Expert colleague. So it's a GDE based in the United States, and he's very good in creating some videos, some tutorials around Firebase. So yes, I do encourage anyone that wants to start working with Firebase and to progress to indeed go to fireship.io. Yeah, indeed.
All right.
Okay.
Okay, now we're really at the end. Renaud, very much thank you for being here. We thank you a lot. It was great having you. See you next time.
Thanks for having listened to my talk, and I wish you all a nice Christmas.
Yes, thank you for you too.
Thank you. Bye-bye.
Oh, people don't hear me? Yeah, now people hear me. It's getting late, guys. I forgot to put the music on. But what I was saying is that I want to thank you, everybody, for staying with us. It was quite a long evening, but I actually saw even some new people joining the further we went into the session. So I think it was interesting for everybody. And I want to conclude this session just by saying that I think it's great that you're all here, that we are sharing the serverless spirit, serverless mindset, even though Mark doesn't like the word. Sorry, Mark. But let's keep doing that in 2021. Let's keep building our community. If you want to speak or give a session, you just send an email to admin@serverlessdays.be, and then we see you, no doubt, on one of the next meetups or the conference next year. See you guys. Have a great night. Bye.